everybody, it's Monaco here.
And Milks.
It's our fourth video in the unit series. We're getting into what we call nomenclature of chemical compounds. We're doing the ionics first.
Yep. Nomenclature, we are going to learn how to name them.
Nom, nombre, nomenclature, has to do with those Latin roots.
Right. Nomenclature is just a fancy word for
naming.
How do I name it?
How do I name it?
All right, so first thing first. There's going to be a lot of notes coming up on this page, so I actually want you to watch it one time first.
Then rewind it.
And then rewind it.
And then take your notes.
Right. So you get a feeling, because I'm going to fill this whole thing up, and I'm going to take it away and fill it up again, and you don't have that much space.
Okay, so for space purposes, watch the next couple minutes.
Yeah.
Then rewind it, and then write your notes.
Sure, I'm good with that. You don't
so
need
you
to
can
rewatch the whole thing.
plan your spacing out.
Just a little bit.
Yeah.
Right. Because there's a lot here to learn.
So naming simple ionic compounds. First name, middle initial, last name. That's like me, Joel T.G. Monaco.
There you go.
But that's not like me.
Well, no, look, here we got this. FeCl2.
Iron and chlorine. There's nothing in the middle. How would it need a middle initial?
Well,
I would call that iron chlorine 2.
You'd be really, really close.
Okay.
If you look on your periodic table,
yeah,
you're going to see that those middle metals,
the transition metals, 3 through 12, anything
right,
in there.
Iron in particular in this case,
Group 8, period 4, got it.
has 2 possible oxidation states.
And oxidation states, you mean the 2 possible different ways it can lose electrons. So
right.
Iron could, according to my chart here, it could either lose 2 electrons and be a +2,
right?
Or, since it's unpredictable,
it
could lose 3 and become a +3. So it has a couple options.
It does.
So
this
that
naming,
has something to do with
this
the
naming system. We're going to learn.
Okay.
The middle initial is going to tell me which iron I used.
The iron the 2
or the iron the 3. Got it.
Okay.
So let's go through this.
First name iron, middle initial 2, 3, last name chlorine.
Let's just go through the notes and you're
going
to
figure
figure this out.
I'm just going to stop jumping ahead.
All right, so
first name.
First name is simply the name of the metal.
Metal. Iron's a metal.
It is, so we're going to say the first part of this name is iron.
Iron. And if I didn't know my names and symbols,
flip it over, table S.
when in doubt, check S out. Okay?
Okay, so now this whole middle initial game
starts to come into play.
Right. The Roman numeral is what our middle initial is going to be.
The charge.
It is the charge, or the selected oxidation state on the periodic table.
So selected means optional.
True.
Oxidation
It
state.
could be one or the other, but I need to know which one.
Okay.
And when we learn in the next slide, you're going to see that it makes a big difference.
It does.
It does really make a big difference.
So in this case, you're saying it's a +2.
I am saying that this one is a +2.
So we'd put in between iron and chlorine the Roman numeral 2.
There you go.
In parentheses.
In parentheses.
Okay. Just because we're talking about
Right.
iron 2,
Right.
not iron 3, which would be the Roman numeral 3.
Oh, it's such a jinx. We said that at the same
Tell me
time.
the code. Now you can't speak for the rest of the movie.
Oh, here we go.
Uh-oh. And then the last name is the name of the non-metal. Add the suffix of "ide." So chlorine-ide.
No. I'm going to take off the Ne of chlorine, and then add the suffix
"ide."
Yeah, ide. So take off the INE, add ide.
Okay, ide. All right.
So that leaves me now with iron 2 chloride.
And a point of clarity, chlorine usually only forms a -1 ion.
Right.
So 2 chlorines, which is a -2, and the +2 from the ion
cancel out
from our last video.
Right. We're going to learn a little bit about how to do
Now,
that.
if this was iron 3 chloride, I'm going to predict that the iron has a +3, so it would need...
Because the Roman numeral is the charge.
Yeah, so the iron would be +3. I would need 3 chlorines.
See, now that's why I'm saying it's so
balance it
important
out.
to name this one right. But we're going to learn how to go from name to symbol, and then it's really going to hit home.
So we got an idea. So that was the first step. So let's see what else we got here. Iron 2 chloride. Got it.
So let's do one that might be even a little bit easier.
Let's see why this would be easier here. So calcium is the first name.
Yo.
Metal.
It's got a +2
Middle
charge.
initial. Middle initial. I'm going to look for calcium. There's only one selected oxidation state, so there's one option.
Right.
So calcium, Roman numeral 2, chloride.
Okay. Well, because there's just the one option, we really don't have a choice. It's got to be a +2, so I don't have to name it in a way that tells you what it is.
It's not like a cousin or a junior or something.
Yeah, it
It's not like iron 2 chloride. It's not iron 3 chloride. They're
It can
different.
only be calcium 2, so I don't even have to say it.
Okay. If
So
you
this
did
one
put
is-
it in there because you want to be consistent, are we going to get you?
No.
No, we're not
No,
going to be
but,
jerks.
But then you'd be doing too much.
But you'd be doing it right and too much.
Well, yeah, you'd be doing it. You'd be doing it all right. So this one could be calcium chloride, simple as that.
It's not calcium chlorine.
No, because again, with my IDE, I need that I at the end.
That tells you that they're ions or
Yeah.
compounds, I think.
And as a matter of fact, one of the things I do a lot is with those halogens. I
Mm.
call them halides all the time by accident.
Halides. Yeah,
Yeah.
that's because you worked at Kodak. It's fine.
You know, well,
I'm allow it.
okay. Well, they all form ides.
All
So-
compounds pretty much add it.
Seed, so it happens.
Anyways,
It
cool.
happens.
So, finding the formula for simple ionic compounds from just the element symbols.
There you go.
Hmm.
So let's stick with let's go through just MgO first.
We call this the crisscross method for some reason.
You're gonna see why.
Oh, okay. Let's see what we got here.
All right. So step one, I'm gonna write the symbols of my elements. Right. So it said magnesium oxide. I have magnesium and I have oxygen. I'm gonna write magnesium and write oxygen.
Okay.
That's right here.
Right.
And then step two,
Write the charge, oxidation number of each ion above each symbol. So I'm looking at Mg. It's a +2. Oxygen's a -2. There aren't any other options.
so we're good, right?
Okay.
So it's Mg +2, O -2, and then you see the arrows right here. Let me switch colors. I'm going to take that 2 and bring it down to be the subscript of Mg. That's
Okay.
right here.
So you're swapping charges likes.
Right, except where it says ignore the plus and minus. Like just bring down that number.
The number. Okay.
Okay, and crisscrossing it down gets me to this
Mg2O2.
which is 2 Mgs for every 2 Os.
It's a ratio.
It's a ratio.
Okay.
And then number 4 says reduce the subscripts to lowest terms if I can.
To give
And
a
2
special
and
type
2,
of formula.
I can divide both of those by 2.
Gets to ones.
Gets me to Mg1, O1, and I don't have to write the 1 in a compound like that because it's a given, right? If I write Mg, there's got to be at least one Mg added.
Can I add something to this?
Okay?
It's exactly what you were talking about, but I'm going to do the A, B, C, D.
Okay.
Atoms, brackets, charges, dots, just to kind of help maybe a little bit here. So atoms, brackets, charges, dots for Mg and O. So I got an Mg, atom, bracket, says the charge is +2 there. I'll do O in a different color. O, bracket, said the charge was -2 there. And then I'll put the dots in for oxygen. It starts with 6. So I know this, well, because it's a chemist and I just know these. No, I looked at my periodic table.
Yeah,
And then there's the 2 black dots from magnesium. Atoms, brackets, charges, dots.
Right.
So if I look at these charges up here, a +2 and a -2 cancel each other out.
And now they're in a 1-to-1 ratio.
1-to-1 ratio. So that's why MgO is our final answer there, and not Mg2O2. So you're telling me this crisscross method is a shortcut that won't make any sense unless you already know about atoms, brackets, charges, dots, and charge cancellation.
Basically, this is the quick way to go from the written word of the compound
Magnesium to oxide
to the
formula.
formula.
So this is name to formula.
Right. Now let's do the calcium chloride next piece.
Okay? Go
Okay.
for it.
So I got calcium chloride.
Calcium
Right.
2, chlorine,
Yep, calcium
Okay.
2 chloride.
chloride. All
I'm going
right.
to take my calcium and my chlorine and write them down.
Got it. Ca and Cl.
Step 2, write their charge and the oxidation numbers above.
Calcium can only be a +2.
There it is.
Well, hold on here. Chlorine's got a -1, a +1, a +5, and a +7.
Would I ever take a plus and add it to a plus?
Not if you want them to cancel out to 0.
There you go. Besides, 2 positive magnets do what?
Two positive, opposites attract, so likes repel.
There you go. So we can't repel if we're going to be a compound. We need something
You
to
attract.
So
Compound
we need
means
the
you are
opposite.
attracted
It's
and stuck
always a
together.
positive and a negative. Positive comes first.
For ionic bonding, it's always a positive. Yeah.
Thank you. So I have a -1 is going to be my choice now for chlorine. And this is where the crisscross comes in very, very handy.
Because it's the only negative
I'm gonna-
option.
I'm going to bring down the 1. It's going to go to chlorine. And I'm going to bring, to calcium. The 2 is going to come down to chlorine as my subscript, which means for every 1 calcium I give, I need two
two
chlorines.
chlorines to balance it out.
And that's written right here.
Yep. Can I do the ABCDs? to
Sure,
help?
let's do it.
Sweet. All right, atoms, brackets, charges, dots. I got my calcium atom with the brackets on it. We said it was a positive 2 ion. Now, chlorines. And this formula says there's 2 of them. Okay, so I'm going to draw one chlorine here with its brackets, its charge, and one down here with its brackets, its charge. Okay. Now I got to put in my dots. Chlorine starts with 7. And there, so that's 2 of them. Started with 7, and it has 1 electron each from the calcium. And if I look at my charges canceling out to 0, calcium's a +2, minus 1's +1, minus another one is 0. So I needed 2 chlorines to cancel or take the electrons from my 1 calcium.
Right.
And this crisscross method that you're showing us, Mr. Milks, is like a shortcut to take it from just 2 elements
With their
to a formula.
right, with their oxidation states.
So
with
the
their
type of
charges.
question you could expect is something like, what is the chemical compound formula when you combine potassium and oxygen?
Correct.
That's the type of question that this is useful
That's
for.
exactly right.
Gotcha.
And
Okay.
listen, and this is a real good precursor for us building stable atoms for next unit.
Okay. Cool.
Because we're going to need to be able to build stable atoms from scratch.
All right. Let's see what else we got here. So ionic compounds that contain a polyatomic ion.
Right.
Oh,
So
gee.
my saying with when in doubt is definitely check E out.
Look at that. Polyatomic ions. It's in
Yep.
the
Table
title
E.
of the table.
Every one of them has a name. The trick for you guys at this point is doing them enough that you know which ones are on this table. You can pick them out.
Which ones are
So-
called? How do you identify
Yeah,
them?
how do you identify them? It's really going to be the key here. So, first example, I have calcium with a CO3. CO with 2 capitals is not on the reference table.
No.
Capital C, little o is, but capital C, capital O is not.
CO3. Looks like there's a CO3 right here, Mr. Milks, but it's
There
got a
is.
-2 on it.
Well, that works out really good because what is the charge on calcium?
Calcium, looking at my periodic table, +2.
So now we're in a 1-to-1 ratio.
Yep.
If I did the crisscross method, they'd go 2-2, reduce down to 1-1, and there we go. 1 calcium, 1 CO3, which happens to be from table E, a carbonate.
Carbonate. So let's do atoms bracket. No, we're
No.
doing first name, last name.
Yeah, let's just do names for right now.
Name the metal.
Name the metal, Ca is
Calcium.
calcium. And then we are going to simply
Name
name the polyatomic.
polyatomic ion.
We don't have to put an I at the end. Table E says
Carbonate.
carbonate, and guess what? We're
Calcium, carbonate,
Done.
Dunsky.
That's it.
All right. That's actually really easy.
That part was a lot easier, but that's where the trick is now. Can I identify that CO3 is a polyatomic?
For me, the 2 parts of this lesson that are going to be the hardest are figuring out the Roman numeral for a element that has multiple options.
Right? Say it with me now. The Roman numeral is the charge.
Charge. And on our reference tables, it's the selected oxidation states.
Right.
And selected means optional.
Yeah, which one do I
Do
need
you want to
to
select?
make it right?
Which one was selected? Polyatomics keep their given name in table E. And the other part about the lesson that's really important is that crisscross method where you're canceling the charges on the ions out
Yes.
by adding more of them in. And the crisscross method makes that mathematics simple for us
Right.
because of, I think it has to do with the multiplicative property in mathematics.
Oh, here we go.
But don't let me get you out into the weeds on that one.
Right.
Because if you don't understand this concept, all you need to lurk around the internet and look up some of these things called charge cancellation technique,
There you go.
the crisscross method,
Yep. Building stable compounds.
nomenclature of ionic compounds is
Yep.
another one too,
Yep.
and
And polyatomics.
polyatomic ions and formation of ionic compounds.
So this was a fairly long video. We covered a lot of things. So now we need to do a lot of practice
Practice.
with these things. So see you guys tomorrow in school. Thanks for listening.